This tutorial will help you to solve the problems on homework number 15. Let's get started. Question 1. Find the solution to the system of equations graphically. In order to do that, you must graph each linear equation on the same coordinate plane to see if there are any points of intersection. If there's a point of intersection, then that means that that ordered pair, right, that pair of numbers, satisfies both equations. That means whatever the x value and the y value are, it would make a true sentence if substituted into the first equation, and it would make a true sentence if substituted into the second equation. So let's begin. We've done this several times already. This is the y-intercept, and that is where we begin graphing, right? The number in the B position is where we begin graphing. So on the y-axis, I'm going to count up to positive 4. 1, 2, 3, 4. Make my first point. And my slope is negative 3, right? A rate of change is a fraction. So if it doesn't have a denominator, fill in a positive 1. So let's make some more points. Starting from our y-intercept, let's rise negative 3, because the numerator is negative 3, and let's run positive 1. Negative 3 on the y, positive 1 along the x. So the change in y is negative 3, the change in x is positive 1. Down 3, right 1. Now you can always reverse this by changing the signs of the values, and instead of going down and right, I may move 1, 2, 3 up and 1 to the left. This is my first equation here. So my first equation, which I graphed in blue, I'm going to label it with the letter A, and then this way when I draw my graph, I don't have to write the whole equation, right? So that's a faster way. All right, the second equation I'm going to call B, and I'm going to graph that in red. My y-intercept is minus 2, so that's a negative 2 on the y-axis, and my rate of change is positive 3, or 3 over 1. 1, 2, 3 up, 1 to the right. We saw that? My red point is on top of my blue point, so that is a point of intersection. 1, 2, 3, right 1. Change in y is 3, change in x is 1. Remember, I can reverse that. Instead of up and right, up and right, up and right, I can go down and left, down and left. Now I'm going to connect my points. Oops, that was a little crooked. Let me try again. Connect my points, draw my arrows, and label it with a B. Now this green point right here that I'm marking is my point of intersection. So that is my solution, 1, 1. Let's start on question number 2. Question number 2, I'm going to graph the first one in green, letter A. So that's 2x minus 2. Minus 2 is my y-intercept. And 2 over invisible 1 is my rate of change. Up 2 over 1. Up 2 over 1. I'm going to keep going until I run out of room or hit the edge of my graph. Now instead of going up and right, I'm going to reverse it. Down and left, down and left, down and left. Now you should use a ruler when you connect your points, and don't forget to always label it. So I'm taking a little shortcut by labeling them with letters instead of their actual formulas. All right, letter B. Let me make this a little bit thicker so it's easier for me to graph. Okay, start at the y-intercept, which is 3. And then my rate of change, right, my slope is rise 1, run 3. Rise 1, run 3. Up 1 over 3. Up 1 over 3. I ran out of space, so now I'm going to reverse it. Instead of up and right, I'm going to go down and left. Down 1, 3 to the left. And as I was drawing, I did draw an overlapping point. So that right there was my point of intersection. And its coordinates are 3, 4. Okay, last one. This one's a tricky one for some kids because the B position number is missing. And if your B position number is missing, that means it's technically a 0. So I'm going to call this one line A, and I'm going to make it thicker again so it's just a little bit easier for me to graph. So I'm going to start at 0. And now my rate of change is up 1 over 2, up 1 over 2, up 1 over 2, And now I'm going to reverse it. Down 1, left 2. Down 1, left 2. Connect my points, draw my arrows, label my line. And now for the second one. The second one, I'm going to label B, and I'm going to graph it in blue. So its y-intercept is -4, and its slope is up 5 over 2. So rise of 1, 2, 3, 4, 5, and run of 2. 1, 2, 3, 4, 5 over 2. Now let's see if I can reverse it. Down 1, 2, 3, 4. Nope, I run out of space if I try to reverse it. So now it's important to have a ruler because my line doesn't go all the way up and down with my points. Okay, now the point of intersection for this graph here is, let me mark it in green, right here. And that is the point 2, 1. And that is how you graph systems of equations. Box number 2, state if the equation shown is a linear function or not a linear function. So here we're looking for 3 things. No powers other than 1, right? If you have a power other than 1, then you are not linear. We're looking for no variables in the denominator. Variables in the denominator technically have negative powers, so that again is the same rule. The third rule is no products of variables, so no x's times y's. So let's see what we've got here. Number 4, any powers? No. Any variables in the denominator? No. Any x's timesing y's? No. So this one is linear. Second question, any powers? No. Any variables in the denominator? No. Any products of variables? Nope. So this one is also linear. This one has a power, so that breaks the rule. That is non-linear. This one does not break any rules. No powers, no variables in the denominator, and no products of variables. So this one is linear. Number 6 breaks a rule. Do you know what rule it breaks? No variables in the denominator. So that is non-linear. And now for this one. This one's a little confusing, so I'm glad it's on here. You see these absolute value bars? Okay, those are not allowed. Kind of like powers are not allowed. So absolute value bars are not allowed. Square root signs are not allowed. So this one is non-linear. All right, now this question was asking you about if something was linear. The next question is asking you if it's a function. See, you can be a function, but that doesn't mean you're linear. And you can be linear, but that doesn't mean you're a function. So these are 2 different questions. So I want to make sure you're paying attention to the vocabulary here. If you are a function, every value of x can only pair with one unique value of y. So when we have a graph, we use something called a vertical line test. So I'm going to draw a vertical line here on my paper. And I'm going to take this vertical line, kind of like your pencil. You could use your pencil like this. And I'm going to scan the graph from left to right. And the rule is, if I touch the graph at more than one place, then I am not a function. So this is what I mean. Let's take a look at number 8. It's a little easier to explain. You see, as I'm scanning the graph, I am touching the graph both here and here at the same time. So you can't touch the graph twice at the same time, because that would be repeating an x value. So this one, that doesn't happen.
Sorry, I don't know that.
For this one, it does happen, right? See, that fails the vertical line test. So this one is a function, and number 8 is not a function. Now the vertical line test only works for graphs. It doesn't work for tables. But tables are even easier. When you have a table, all you're looking for are repeating values of x. No repeating x values with different y values. So I have a -2 and a +2, but that's not a repeat. A repeat is the exact same number with the exact same sign. So this one is actually a function. All right, let's turn the paper over. Pablo says that the relation shown is a function. Is Pablo correct? Explain on the lines below how you determined your answer. Well, remember what we just talked about? A table is the same thing as a list of ordered pairs. And the rule is no repeating x values. They have to be all unique. So let's take a look at all of our x values. I have a 2, a 4, a 6, and a 2. Are there any repeating x's? Yes. Therefore, Pablo is not correct. Pablo is incorrect. And then it says, explain how you determine your answer. Pablo is incorrect because there are repeating x values with different y values, right? There are repeating inputs with different outputs. That is not allowed. Okay, let's take a look at question number 11. Solve this equation. So on the left side, I'm going to combine like terms and get 3x plus 5. And on the right side, I'm going to distribute and get 3x plus 12. Now, if you've done this before, you might be able to look ahead already. Right, I have matching variable terms here, but on different sides. So 3x plus 5 is equal to 3x plus 12 can never be true, but let's prove that. If I subtract 3x from both sides, I get a double cancellation. And that leaves me with this statement that is not true. 5 is not equal to 12, so technically there is no solution to this equation. There's no possible value of x that would work. All right, let's take a look at this last section here. Find the rate of change. You're going to use your y minus y over x minus x formula. This should look familiar to you. We've been doing it for a few weeks. So these are the y's, and the first values are the x's. So y minus y over x minus x. So negative 1 minus 8 is negative 9, and 3 minus 3 is 0, and you are not allowed to have a 0 in the denominator, so this is undefined. All right, question number 13. Identify the rate of change. Well, the rate of change is the value in the m position, right? The coefficient of x. But that only works if you are written in y equals mx plus b form. And number 13 is not. And that's because y is not alone. Right? See that? Y has a coefficient. So we're going to clear that coefficient by using an inverse operation, dividing everything by 5. And now I can use the shortcut. So identify the rate of change. The rate of change, the ROC, is the coefficient of x, which is 2/3. Number 14, which of the following is not a linear equation? Remember what we were looking for? No powers, no variables in the denominator, no products of variables. So it looks like we have 2 here. These are both nonlinear. And then the last question says, which of the following graphs is not a linear equation, right? Remember, linear means to be a straight line. So if you are not a straight line, then you are not linear. And that concludes homework 15.